Hey, Mr. Smith, how's it going? Oh, you're waiting too long for hot water. Okay. Yeah, I can get over there. I'm in the car now. Yeah, I'll come right over. Sounds good. Okay, let's try it. Wow. Eric, what are you doing here?
Oh, man. Hey, Ross. Well, I'm just measuring the water.
Measuring the water, all right. What was that? I don't know. Let's go take a look.
Perfect Plumbing Plan, a Build Original series brought to you by SharkBite.
All right, guys. Now that we know the problems, I've got the guys who are going to help you find the solution. By way of introduction, my name is Matt Reisinger. I'm a builder, and I've got with me here Eric Ani, a master plumber, not just any plumber, a master plumber.
The master.
And Ross Trathui, an engineer who does this day in and day out from the engineering side, from the pre-construction side. Mm-hmm. So with that being said, Eric, where should we start on helping these guys find the perfect plumbing plan?
Okay, I have a little activity I want you to indulge me on.
Okay,
all right.
Sounds good.
Ross, I'm going to give you these 4 pieces of pipe.
All right.
I just want you to hold those.
Right. Sure, I can hold those.
And if, in case you're wondering, this is something we learned from our friend Gary Klein.
Gary is awesome. We've learned a lot from him about hot water.
We'll give you that. Ross, you have 1 inch, 1.25 inches, 1.5 inch, and 2-inch PEX pipe.
Got it. Okay.
Matt, 3/4 inch.
3/4.
There's some 1/2 inch.
And some 1/2 inch.
All right, so all of these things have something in common with each other, right? Obviously, everybody watching knows that they're plastic.
Yep.
Doesn't really matter.
They're all PEX.
Yep, they're all PEX. They're all different lengths, as we can see that. Any idea, Ross, what you think is going on here?
I'm not really sure. Yeah.
Okay. Well, I've got 18 feet of 1/4 inch tubing. All right.
Wow.
That's a lot.
Yeah, so we've got just about 6 feet of 1/2 inch. We've got 2.5 feet of 3/4 inch. And then we have the various sizes. I think it's 18, 12, 9, and 5 inches, actually, believe it or not. I'm surprised I remembered all those numbers.
It's impressive.
That was impressive.
The point of this demo is to show you that each one of these pipes holds the same volume of water.
Wow. How much volume is that?
It's right around 1 cup of water. If we've done the math right and we've done everything right when we measured, but we should be able to fill every one of these pipes with 1 cup of water.
So check this out, Eric. This length of 3/4 is just shy or right around a half the length of the 1/2 inch pipe, right?
It is, and so that's going to matter when we get in further into this series. We're going to talk about delivering water, the time to tap, right?
That's
But
right.
we're going to try to do it by waiting the shortest amount of time, wasting the least amount of water.
That's right.
So
And
what's
we
the
get-
problem with wasting water in your mind, Eric? Is this strictly that there's a limited amount of water and we want to make sure that we're not wasting water? Or are there other issues that come with dumping that cold water down the drain?
I'm glad you asked, because I'm going to answer that question. The number one complaint I get from customers, waiting for water is very annoying by everybody. I don't know anybody that wants to sit there and wait and watch water go down the drain.
Yep.
Yes. And then number 2 is running out of hot water.
Yeah.
Okay. Yeah. Nobody wants a cold shower. As we saw at your house, waiting for that water is annoying, and it's also very wasteful. What happens when we heat water? We've paid for energy to do so.
Yep.
We've had to pay for some sort of energy to get the water to your tap in the first place. So
Good point.
we have a bill, a water bill, or electricity on your private well. So there's a lot of things that go into wasting water that are in kind of ancillary to it, the cost of it, and then the resource. Right? I'm going to talk more about the logistics of everything based off of my experience as a plumber. I'm going to talk less about the resources.
Yeah. Let's jump into a little bit of the differences of what people are going to see out there, both in older houses, but potentially also in new construction. And I'd love to get you, Eric, to give us a quick rundown on all the different varieties of plumbing pipe, the way that we deliver water to our fixtures. And then we're going to actually get into some of the specifics and differences.
Yeah, so what we see normally in traditional construction was copper tubing, right? You see a lot of copper tubing out in the marketplace, and we still use copper today, although it's considerably less common than the PEX products.
Sure.
Right? And so traditional water distribution in a residential application, we start at the water heater. Maybe you live somewhere where you have a basement, or you've centrally located that water heater slab on grade, maybe like a garage or something like that. And then we run what's called a trunk and branch system. So we've got a hot and cold main, and then off those mains, we branch to fixtures. Very simple, straightforward. Anybody that's been in or around construction can visualize that and picture that, because that's what we've been using forever.
That's right. Yeah.
And Ross, is there any difference between these two pipes you've got?
Yeah. So they look the same, and they actually are the same OD, outer diameter, but they're actually different inner diameters. And the difference here is that we've got copper type M and copper type L.
Huh.
And so in some
How do you
markets,
tell the difference?
Yeah, so it's funny. You can look at the label on it. If it's a red label, it's type M. If it's a blue label, it's type L.
Okay.
And so in some cases, in some jurisdictions, you only can run type L. In some other jurisdictions, you are allowed to run type M.
And if you look at it, can you tell that?
You
You can kind of tell a little bit on that wall thickness,
wall
can't you?
thickness is
If you
different.
look tight on there, you'll see one definitely, even with the, without using a micrometer, you can tell, this
You
is
can
a little
tell,
thicker.
yeah. And so this is very common in older houses, as Eric mentioned. But now modern plumbing is all pretty much done with PEX.
Yeah. Now, before we move on from copper, Eric, I've seen you use this guy before, and for years, we only had sweat-on fittings, but in the last decade or maybe longer, there's a new type of fitting called a press fitting, right?
Yeah, so it looks like a copper sweat fitting. I think we have some on the table here.
Yeah, there you go.
Here's a copper 90 here. We'll just show it. Same materials are sweat fittings, right? But machined into the fitting are a couple different sealing elements, an O-ring. And we put that together by slipping it on the end of the pipe. And we've got a specialized tool, quite expensive. Now we've gone away from flame, no chemicals.
Less chance of fire on the job for me as a builder.
Yes.
Yep.
And, injury. Okay. So then I'm just literally pulling a trigger once I've positioned the tool on the fitting.
Yep.
So now I've made a mechanical seal on that fitting to pipe there that is permanent, cannot be removed, and extremely reliable. When we're working with copper on the job sites, I do it a lot with my heating systems as well. We're using press almost exclusively.
Okay.
Because of the removal of the flame, no chemicals, we don't have flux, we don't have to, there's a little less prep involved. We're still installing the piping using the same principles, but we're using a different fitting system, makes it faster, very reliable.
Okay, so then next, let's talk about CPVC. What is that pipe and how is that joined?
Yeah, so CPVC is a variation of a PVC product. It's different chemicals that go into the chemical makeup of the pipe. It's less flexible than a PEX tubing, okay? So because it's not flexible, it's considered a rigid pipe. We typically see copper tube size, or what we say in the industry, CTS, size piping. We're having to use solvent weld fitting systems with CPVC. You could use like a push to connect system, like a SharkBite fitting, but the traditional installation method for CPVC is a solvent weld fitting, so because you don't have the flexible pipe.
For years, I used that as a production builder back in the day. We would use a primer first, a purple primer on the pipe, and then we'd put a clear glue on, and then you'd hold the fitting together. Is that pretty standard still to this day?
There's a couple systems out there. There's even a one-step process with more identifiable glue. It's like a yellow. And so it just depends on what type of, what brand and your suppliers, what is available in your market.
Gotcha. Now we've got a lot of red and blue pipes on the desk here. Walk us through what we're seeing here.
Well, we've covered most of it already, the PEX, right? So PEX is polyethylene cross-linked material, and it's I don't pretend to know every step of the way on how this is made, but it is a few different chemicals that are melted together, I think is maybe the layman's term for it. It's extruded out of a machine. It produces a very versatile piece of tubing, right? So this is super flexible by comparison of really all of the other piping systems. And it's very versatile because it allows us to go around corners, use less fittings, things like that.
All right, speaking of this, Eric, I actually have a surprise for you that I just lined up. There's a private jet in the parking lot ready to go. Get out of here.
All right, see you later. Wow, guys, Atlanta, Georgia, this is RWC's global headquarters. They've just built out this awesome training facility with all of their products on display. I love stuff like this because it's hands-on. Ross, Matt, thanks for sending me here. I can't wait to show you guys what we're gonna see here. And by the way, maybe like a mystery test coming up later on in the series. Let's get going. Pete, how you doing, man?
Hey, man, glad you're here today.
Yeah. Guys, this is Pete Regan. This is your baby. You had a lot to do with putting this whole training center together. It's super impressive.
Thank you.
Yeah, congratulations. I'm excited to be here. Thanks for having us.
Of course.
Pete, we've already started talking in the series about materials, pipe sizes, things like
Yeah.
that. What the heck is PEX A, B, and C? Can we just put that out there right away?
Yeah, 100%. So PEX A, B, and C, it's not a grading scale. That's a big misnomer in the industry.
Yeah.
It's an identifier to help us understand the manufacturing method and cross-linking method of the PEX.
Okay.
So at RWC, we manufacture PEX A and PEX B. So PEX A is a peroxide cross-linking, and then PEX B is a silane cross-linking.
Okay.
So it's just two different systems to get the PEX its strength so that it can be used in your potable water systems.
So PEX, it's polyethylene cross-link. That's what
Yes.
PEX, the initials are. It's like an alloy when we're talking about metals, right? So if we
Yeah.
talk about aluminum, magnesium, we add them together, now we've got this alloy, right?
Exactly.
So you've got two different or multiple different materials that go into making the plastic structure of the pipe itself.
Yep.
When you extrude it out of the machine, that's where we differentiate between A, B, and C. It's just the
Exactly.
chemicals or the process in which the pipe is actually made. Doesn't make one better than the other necessarily.
It depends on the application
Okay.
and the use. So each of these have their place and what they need to be used in the industry. But PEX A, it brings a little bit more flexibility to it.
Okay.
You know, PEX B has different connection methodologies so that you can put your potable water systems in. It comes down to the end user and what do they need? What do they need to gain out of the product? And then we align the right solution to meet their needs.
Okay. So sizing,
Yes.
right? So all of the different types of PEX are available in each diameter size, right?
Yes. So we have at RWC, we manufacture from 2-inch down.
Okay.
So you'll see here we have 2-inch over 1.25
Yep.
on our PEX A. And then we go into the different levels here. So we have it broken up into 1/2-inch, 3/4, 1-inch.
Okay.
So a couple things you might see a little different than what's in the United States is this is a clear PEX heavily used in Canada. And then these two are
Sleeved.
sleeved PEX
Yeah.
to put in your concrete. So in your homes, in your apartments, when you have PEX running through concrete, you can use this product to protect the PEX in the concrete so that it doesn't get damaged through the construction process.
Also just keeps all the materials, whether it's ground, dirt, rocks, anything like that, backfill, right? It keeps it off in direct contact with the piping system.
Yeah, 100%. So it's all about protecting this pipe through the construction process so that the potable water system doesn't get compromised at all.
Okay. So one of the reasons we've focused on PEX in this series is that it's become really the standard in piping distribution in residential construction. We see more and more all the time because manufacturers are stepping up with product offerings in the commercial space too. We're seeing a lot more PEX brought in like a hybridized kind of system in commercial. We might see larger diameters, but when it comes to housing, we're talking a lot about small pipe for distribution. PEX A. Let's talk about the fittings and just kind of you already covered the size, but let's talk about the fitting system. So PEX A, I know it as an installer, having worked with it for decades now. We're expanding the pipe and putting a fitting inside of the pipe that's been expanded.
Yes.
And we cover this in the series too, but we have PEX B, which is not an expansion pipe.
Yes.
So that comes down to how the pipe was made, right? Like
Correct.
the chemical makeup of the material itself. We don't
Yes.
expand PEX B, but we can expand PEX A.
Yes, so PEX A has memory.
Okay.
So the manufacturing process with the peroxide cross-linking allows the PEX to be expanded out, like you said, so it goes wider, and then it has memory, so it comes back around the fitting to create the seal around the barb of the fitting.
Yeah.
And you would use an expansion ring around it as well as part of the sealing process.
Okay.
Whereas PEX B, typical uses with a clamp or a crimp ring and a barbed fitting. And those are the two biggest uses of those two fittings. But, with A, you can use crimp, clamp, if that's what you're more comfortable with, if you want the more flexibility of the pipe.
Right.
B, though, you can't go back and use F1960, which is the code, the expansion fitting on that.
Okay.
So you can go A, you can use the other fittings from B, but with B, we can't use the expansion fitting.
One thing you should know too, though, I like that you brought that up.
Yeah.
So we see a lot of product out in the field as a plumbing and heating like service contractor. I have to I had to make the decision for the vehicle. What are we going to keep on the vehicle, right?
100%.
What do I see the most of? Well, I live in a market that I see all of it. And I think that's true all over the country, right? Mm-hmm. So I see A, B, or C pipe. I see all the different fitting systems. Some of them are way more common in my area than others.
Yep.
You know, but if I go with a B style fitting, the insert fitting with some sort of ring on the outside that I have to either press or clamp, that covers me no matter what the size of pipe is, right? However, it would be remiss if we didn't bring it up, RWC.
Yep.
Everybody knows SharkBite as the push to connect fitting. It's become like the Kleenex of brand names, right? But that's a product that RWC handles, and that's your product, right? Mm-hmm. That can be used on any type of PEX as well. It doesn't matter what type it is because it's inserting on the outside of the pipe.
Yes, it's a great universal balancing tool. If you have a service truck and you just don't know the exact situation you're going to walk into, it allows you to jump from A to B or copper to PEX or CPVC to PEX, depending on what your team's trying to accomplish. It's one of those universal tools that you can use as needed to get your client's water back on.
Yeah. Well, let's get back to the fittings. Let's go further into the fittings. We've got some of them here.
Yes.
And let's point out, just like here, you've got a coupling and there's another coupling here. These are A and B couplings. Here's a plastic one, right? So it's going to be hard to show on camera, but this black plastic fitting or engineered plastic is an A fitting. Right, so that means that the pipe itself would have to be expanded to go onto this fitting, and this brass coupling, for the same diameter pipe, is smaller, and that's what I was going to say. It's almost hard to show that on camera.
Yep.
But we pointed out in the series already is that we need to expand the pipe, like we just talked about a minute ago, and then we use a special tool for that. With the Milwaukee style or DeWalt style is kind of the most common in our market, in North America. We use that fitting to expand the outside of the pipe. There's another product involved.
Right? Expansion ring.
We got the expansion ring. This gets placed on the tubing itself. Mm-hmm. We use our tool to expand it because we cannot insert this. That's the whole point of this, right?
The whole point of that.
My point of bringing this up, slightly higher flow rates. In most residential applications, I don't think we're going to notice the difference.
No.
Right?
Yeah.
That's something that gets brought up a lot in our videos that we've talked about here on the network in the past. We've seen a lot of demonstrations on how maybe this type of fitting system is better for distribution piping, but I'd make the argument that I don't think my customers under normal circumstances are going to know the difference.
Most customers under normal circumstances would not know the difference, even in some of those more commercial, multifamily applications as well.
Okay.
Because when we restrict flow, it picks up maybe a little bit more pressure, so the system will run.
And we've proven too that with these outdated code standards that we're sizing our pipe off of, we're already oversized for what we need to deliver in the system, right? Our pipes are typically oversized for the demand put on them.
We have fixtures that are pulling a lot less usage compared to what they were when these codes were generated and the charts were generated. So now we're trying to understand what is the right size to today's need.
What he's talking about is just literally getting the water to the fixture, cold and hot, and not having that large volume of water just sitting there stagnant, cooling down, taking more energy to reheat and replace. So Pete, awesome talk. I appreciate being here. This is so cool. Guys, stay tuned, but we're going to have more to share from the RWC global headquarters here at their training facility.
So we've got PEX A and we've got PEX B, and it may be a little bit difficult to see this on camera, but I can usually tell by flexing the pipe whether it's A or B. A is a little more flexible, and B tends to be a little stiffer, not so stiff that you can't bend it, but typically if I'm using PEX A, there's a lot more places I can get that pipe to go without a fitting. And then on PEX A, I can either use an expansion fitting or a crimp fitting on there too, right, Eric?
Yeah, so we've got some different fitting systems up here, but we've got one more pipe I want to mention, we don't forget about it.
Oh yeah, okay.
It's actually called PERT, and it looks and feels and acts basically just like PEX, right? So it's a plastic PEX, looks the same as all the other pipes up here. It's just not cross-linked, so it's a polyethylene, and it's PERT, okay? So we call PEX PEX. Yeah, PERT, it's polyethylene raised temperature, I believe is what that stands for. But the point of it is this. It's an alternative to PEX because it's extruded differently. In the process of extrusion, they heat it up or they don't or something like that. I don't know exactly the terminology behind it, but the point is the end product acts and installs just like PEX.
So this happens to be Legend's Hyperpure. They have their own line of fittings, which is a push-to-connect fitting from Legend. But we can also use, let's say, SharkBite fittings on that, and we can't do expansion on this, though, technically.
Technically, it's not engineered for expansion. I've heard of people doing that. You do want to follow the installation guidelines from the manufacturer. Legend's system is really they're in distribution. Guys are using different fitting systems across the different pipes. Of course, I prefer to go with the brand manufacturer's system.
Yeah, makes sense. All right, so we've got two types of fittings that we can do on PEX, depending on if it's PEX A or PEX B. On PEX A, we can use an expansion fitting. And Eric, what's the difference or what's the benefit for using an expansion versus a crimp fitting?
So an expansion fitting is the ID of the fitting itself is the same as the ID of the tubing it mates up with. So if you have a 3/4 inch 90, like I have in my hand here, this is for cold expansion tubing or PEX A. And then you have another component. This is a little expansion ring. It's made out of the same type of material that the tubing is made out of. That gets placed on the outside of the tubing, okay? But we use this expansion tool. We have to enlarge the size, the wall of the piping, or we have to stretch it so that we can insert the fitting into the PEX, and then it retracts.
And the cool thing about this that I like is you can't put that fitting in and dry fit it. So in other words, you can't make the mistake of forgetting to crimp something, let's say.
From a plumber's perspective, that's a huge benefit. I've in the past had situations where I have dry fit the insert fitting. So this is the difference between the two, right? So that fitting itself, it doesn't insert into the unexpanded tubing. We cannot insert the tube. Difference being the PEX B style or crimp style fitting can insert directly into the tubing, right? Now, that's because the fitting itself is slightly smaller than the diameter of the tubing itself. So there's a little more of a flow restriction to that.
That's right.
And then another fitting that we haven't got into, which is this SharkBite style. They've kind of become the Kleenex brand or name of push-to-connects. These fittings are pretty interesting because you don't need a tool to install these. These will fit right on the pipe. And the other nice thing about these is that they will work on multiple pipe styles. So you see a lot of retrofit situations, remodel situations, removal of a water heater using these types of fittings because they're so versatile.
They are. They're super versatile and then no extra tools. So like if we're putting together copper these days, we're often using a tool that's upwards into the thousands of dollars, okay? There are some manual tools available out there. I haven't personally used them. If we're using expansion in PEX A, we're using also specialized tools that are relatively expensive. It can be done manually. On the production side, as a plumber, I'm not expanding PEX manually. It just is too labor intensive and it's actually kind of hard on your body. When I can have a tool, do it automatically by pulling a button, that's kind of nice.
Pretty nice. All right, guys, I think we've gotten the basics on plumbing. I think you guys have gotten the basics. What do you think? Should we go to the board?
Let's go to the board.
Okay, let's do it.
All right, let's geek out. Let's get into it. So the first one I have here is about looking at 1 cup of water, the same volume that Eric kind of went through before for different size pipes. So from 3/8 pipe, 1/2 inch, 3/4, all the way down to 2 inch. And so if we have it copper type M, type L, type K, SDR11 to CPVC, and then we also have Schedule 40, and then we also have PEX LPEX, and then PEX SDR9.
That's so interesting to see. Look, between type M copper and type K copper, there's actually a difference in the amount of volume inside those pipes.
That's right, yeah, so it's counterintuitive, but type M has the thinnest wall, type K has the thickest wall, but they have the same OD. So by making the wall thicker, you can think about it, right? If I have the same OD and I make that wall thicker, of course, it's going to decrease our volume.
Right, that makes sense. Okay.
So we can go, 9.5 feet of 3/8 to get 1 cup of water with copper type K versus 7.5 feet to get the same volume.
The other thing I want to point out is look at that PEX down there too, Eric.
Yeah.
Look at that. Quite a bit more.
That's right, 12 and a half feet. So if I have 3/8 PEX going 12 and a half feet, that's going to be equivalent to a 7.5 feet type M run.
Wow, that's
Right?
wild.
And so when you talk about it, same thing with 1/2 inch, right? 6.8 feet versus either 5.5 to 4.7.
And again, the entire chart is just 1 cup of water.
That's right.
Just like you showed us in those pipes earlier.
That's right. Because if we can reduce the amount of volume from the water heater to the fixture, we're going to reduce how much time you have to wait for hot water.
Yeah.
Right. So the other thing too that's very important is that from the 1980s to basically to today, we've seen a reduction in the consumption of water. So we've gone from 3.5 GPM or more for just a regular lavatory faucet, right? Just a regular sink, all the way down to 1.2 in many cases.
Dang.
Shower heads?
3.5 down to 1.2.
Right. So 3.5 or more for a shower head. Now we're down to 1.8, and in some cases we're even lower than that.
That's amazing.
Yeah, and to kind of put a finer point on this, that 1.2 for a lavatory faucet, actually, that's on the high end.
Is that
we,
right?
we see aerators and faucets out in commercial spaces that have the shower head type flow through them that are using half a gallon per minute.
Half a GPM.
Yeah.
Exactly. So a typical lavatory sink now that's water conserving, it's going to be half a GPM.
The thing that I want people to hear on this, guys, that really is taking me a little while to come to is to realize, I've been in the business 30 years now. And frankly, most plumbers, most of the houses I've built until just recently, we really hadn't changed a whole lot in how we plumbed them. But look at the difference between the end fixture and how much that end fixture is actually putting out.
That's right.
We go from these really high draw fixtures to pretty low draw fixtures. And the other thing that we're not really getting into here, and maybe this is a whole nother series, but I've had low flow toilets, I've had low flow shower heads, I've had low flow sinks, and with the right ones and with some newer technology, you don't miss it. Like I remember 20 years ago, people were like, oh, you got to take that thing out of your shower head as soon as you move in because your shower head's going to be terrible. Those days are gone.
They're gone. Yeah, the pressure compensating aerators, which we'll talk about, those make a huge difference. You don't notice there's been a reduction, maybe 50%, 60% of reduction in water flow over time. You don't notice the difference. It feels the same. A 1.5 GPM shower head versus a 3.5 GPM shower head, they're basically the same.
So I think as you guys are watching this from the audience out there, keep this in the back of your mind. Like, how much has the fixture at the end changed over the last even 10, 20 years versus how much has the plumbing behind the walls changed? That's what we're going to be getting into. All right, keep going, brother.
That's right. So if I go to the next one, this is what we're actually talking about, right? If I take a 3/4 inch piece of pipe, right, and I look at the optimum flow rates through these, I need 3 to 4 gallons a minute to get optimum flow rate. And that's called, when I get into the difference between laminar and turbulent flow. Laminar flow is that it's very uniform, that I get this separation under low flow rates, right? But when I have turbulent flow, I get a lot of mixing within the water pipe, right? So this is basically, we call this Reynolds number. When you have a high Reynolds number, you have very turbulent flow, you get a lot of mixing. So if I look at a 3/4 inch piece of pipe and I run 3 to 4 GPM through it, I've got really turbulent flow. I get a really consistent water temperature across the entire length of that pipe. But when I look at this, where I have 1 to 2.5 GPM or very low flows, like 0.75 GPM, what you get is you get a separation. You get this laminar flow. So you can actually get hot and cold separating inside the pipe.
So if I'm reading this right, I'm thinking when I look at this number, I'm getting pretty tepid water out of there before it gets really, truly hot for a long time, which goes back to your number one complaint, doesn't it?
Yeah, you're waiting longer because you have that mixing happening in the pipe. You're not getting rid of that slug of cold water that cooled down in between events, right?
Yeah,
so we draw water from a faucet now, and then 20 minutes from now, let's say, or 2 hours from now, and that water is cooled down, we have to purge that cold water out of the pipe.
Right.
If under the wrong or under suboptimal gallons per minute flow rates, we're going to be waiting longer. So we're wasting water.
Yeah.
So the plumbing code in most areas would dictate a 3/4 inch pipe to move 3 to 4 gallons a minute when shower heads were 3.5 gallons a minute, right? And so it worked great for that moment in time. But now, as we reduce the amount of flow rate, the GPM comes down, we get into 1 to 2.5 or even lower flow conditions where 3/4 pipe is not really the right size pipe.
You could actually
be
make
used.
the case where you might not, in some cases, like a hand sink, that maybe a bathroom group fed by too large of a pipe, 3/4 or 1 inch, let's say,
Yeah.
a hand sink, a lavatory, you could not get hot water in a reasonable amount of time.
That's right.
As long as it takes to wash your hands doing the ABC method, sing your ABCs, you would still be waiting, sometimes minutes long, depending on how far away the hot water source is.
It's frustrating, right? You turn the faucet on, you're waiting and waiting and waiting. A minute later, 2 minutes later, you finally get hot water. It's just annoying, and it's not energy efficient, right? We're wasting all that water and wasting all that heat.
So bigger isn't necessarily better when it comes to plumbing pipes.
That's right. That's right.
Not in the water distribution plan, especially in a house, is not going to help us out.
Right. So if we look at time to tap, right? So this is the thing that I'm really focused on. Time to tap, 5 feet of pipe. So if I have 5 foot section of pipe, this is my pipe diameter. So this is 1/4, this is 3/8, this is 1/2 inch, this is 3/4 inch, and this is 1 inch. So let's just focus on, let's say 1/2 inch pipe.
Okay.
Okay. And let's look at 1 GPM of flow rate. Let's say we're looking at just a traditional, lavatory
Lab
sink
faucet.
faucet. Exactly. So if I have 5 feet of pipe, 1 GPM, 1/2 inch, depending on my pipe material, copper type L, CPVC, or PEX, I'm going to be waiting 6 to 7 seconds for hot water.
Okay.
Open up the faucet, 6 to 7 seconds, comes out through 5 feet.
That's not
Right.
bad. 5 feet. I could wait 6 or 7 seconds.
That's right. But if I had 3/4 feeding that, I'm now going to be waiting 11 to 15 seconds.
That's
or
getting annoying.
1 inch, or I'm going to be running 18 to 26, right?
That's really annoying.
really annoying. And that's for 5 feet of pipe. That's if my water heater was 5 feet away from that shower,
Gosh,
right?
which is not most of the time.
So that's not common. So then let's look at 10 feet, right? So that same example, 1/2 inch. Now I'm waiting 11 to 15 for 1/2 inch.
now I'm starting to get annoyed.
3/4, I'm getting a 1/2 a minute. And then obviously 1 inch, I'm getting up close to a minute.
I think it's worth pointing out too, for anybody watching, when we go from 1/2 inch pipe, the volume of the 1/2 inch diameter pipe, and then we go from 1/2 to 3/4, we've doubled the volume. Right. Okay. In the same footage, but just because of how the area of a circle works, right?
That's right.
And so we learned this back in like 6th grade. You probably forgot it, but when we go from that one incremental pipe size that we're used to working with, we double the volume.
Yeah.
That's why we see with the math double the time.
Yep.
Double, double, double.
Yeah, that's crazy to think about. There's something about that isn't immediately intuitive to me. And your visual demonstration of those pipe sizes, I think, is a great way to kick this off.
That's right.
So immediately I'm thinking, now how do I get faster hot water? How do I make sure that I don't oversize my pipes?
So the next thing is pressure drop, right? So we look at 90-degree fittings, right? Whether they're a long sweep or whether they're a short sweep, we're gonna have very, very different pressure drop, because you can think about how much turbulence, how much vibration is created as the water is trying to make the turn, right?
So this is a bend support, right? And so in some cases you might use a fitting, a 90-degree fitting. Maybe you just don't have these, maybe you don't have the space. But this little support actually allows us to put a 90-degree bend in the tubing without the use of a fitting. And now if I could do this on camera, I'd be surprised. There we go. So now we have a long sweep.
That's right.
But it's still a 90 because it's totally changing direction.
And the friction loss through that bend radius is negligible. We're not going to take into any consideration that. But by
Coldwright's even doing some of these on some built-in ones.
Yeah.
You don't even have to snap in. The manufacturer has done it already.
Yeah, well, they've eliminated the use of a fitting, which increases the friction loss or the head loss through the piping.
Reduces the chances of a leak.
Yeah, well, this, of course, there's no additional connections in this, and there are with these. So leak paths are reduced with that.
That's right.
I like
That's
it.
right. So we can look at all these types of fittings. We call them innie fittings, outie fittings. We have obviously the PEX supports, the bends.
You got some
right?
brass and you got some plastic in there.
Exactly. Yep. SharkBite press. So then if I go here, now I look at it. If I look at the different versions, right? This is basically a graph looking at velocity. So here's 2 feet per second, 4 feet per second, 6 feet per second, right? This is increasing how much velocity is in the pipe. And this is pressure drop. So if I go higher in the scale, that's actually bad, right? We want to reduce the pressure drop through the system. So this right here represents 5 to 6 PSI of pressure drop. That is a lot of pressure drop through the system.
But Ross, this line's totally straight down here. What's going on with that?
Yeah, so if I take PEX and I use the bend support with a long sweep, I basically have it's negligible pressure drop through that bend.
So in other words, it doesn't know that there's a bend. It feels like it's acting
Feels
like
a
straight pipe.
That's right. And then as soon as I go to one type of 90, you see this red right here, I immediately see a jump. And then as I get more and more restricted by how tight the turn is and the orifice opening, how big is the coupling or the 90-degree bend, I get up to really, really high pressure drops. And so if I double the velocity, the pressure drop goes up by a factor of 4. It's the squared, it's exponential. So it takes a significant hit when I start to get into these really, really restrictive fittings, right? Not good, right?
Yeah, that's wild.
So another advantage of PEX in running that through a house versus running the PEX fittings. So the other thing too is number of daily draws in a typical day. So how much hot water is one part of the equation, but also how many starts and stops. Every single time someone opens up a faucet, even if they're not even using the hot water, that counts as a daily draw. And so Gary Klein did some research and looked at how many gallons were used, but how many draws of hot water were used for showers, faucets, clothes washers, and dishwashers and bathrooms. Right? So this house had a family of 2 people. They had 28 draws of hot water in a day. This family of 3, had 106. So think about 106 starts and stops for hot water throughout the given day. And the amount of faucets dominated, right? So the shower usage were typically long run times, right? Some of these cycles for dishwasher and clothes washer, longer cycles, but not the case for the faucets. The faucets dominated the start-stop cycles.
So in other words, if I open my lav and I wash my hands, I might not even wash long enough to get hot water out of there, but I've still spent the energy to make hot water, to put it into the pipe, only to let it sit there, radiate that heat in the house, and lose the benefit of that hot water.
That's right. I wasted that hot water that didn't even actually get to be used by the occupant, in that case, washing their hands. You know,
That's
you
wild.
filled the pipe up, you purged all that water up, but then now it's just sitting there and just radiating heat, like you said. So it's energy wasteful.
All right, guys, let's go back to the table. Let's wrap this up.
On the next episode, we're going to be talking about how to get the distribution of this piping into the house properly, right? So we can get hot water delivered really quickly. We're going to be talking about trunk and branch. We're going to be talking about manifold style, and we're going to be talking about recirculation systems.
We laid down the foundation. We showed you all the systems and the parts. Now, next, we're going to show you how to actually get hot water. In what goal would you say, Eric?
I'd say under 10 seconds using less than a cup of water, or right around that.
Yeah.
That's pretty awesome. With that being said, guys, we'll see you on episode 2 of The Perfect Plumbing Plan. See you next time on The Build Show.
Perfect Plumbing Plan, a Build original series brought to you by SharkBite.